All right, welcome back to another video in this distance learning series. Today, we're going to do an Algebra 1 review this week. We're going to review the exponent rules. This is 100% from Algebra 1, but it's an important skill that we're going to use kind of moving forward, and certainly, in upper level math, you've got to be comfortable working with exponents all over the place. So we're going to just talk about that today. There's really kind of 5 rules you're going to talk about. I'm going to try to do kind of a logical approach, not so much. I'm going to show you the formulas of kind of what you would see in a textbook, but we're not going to start with those. We're going to start with a very kind of normal, kind of common sense approach to these. So we're going to jump right in here and look at the first one. So if I showed you this, so if you have x to the third times x to the fourth, what do you think it would be? You might have said it was x to the seventh, and that is in fact correct. So let's take a look at why that is. Well, if we have the x to the third right here, we know there's 3 x's. And if there's x to the fourth, there's 4 there. So we have 7 total. So that's going to be what our answer is, right? So that kind of tells us, though, what to do. So anytime you're multiplying the same base, and the base does have to be the same, then all we have to do is add the exponents. Okay? So pause the video for just a couple seconds, or just try to do it in your head, and see if you can figure out what the answer to this would be. Again, applying the same rule, so just taking base by base, so adding the bases, adding the exponents for the m's, adding the exponents for the n's, and then the p's. We should get n to the third, n to the fourth, and then p to the sixth. Remember, if you don't see an exponent, the exponent is going to be 1, so there's 1 here, there's 1 on that m, which is how we got the final answer here. The way you would see it in a textbook is this. You would see, they might use different letters, but that's how you're going to see it in a textbook. Again, if the bases are the same, we're just going to add the exponents. What about if we're dividing like bases? Well, we have something like this. Again, if they just think kind of common sense wise, what do you think that would end up being? Well, you probably said x to the third, because if you write that out, we have 8 x's on top, we have 5 on the bottom. We know we can cancel out things that are the same, so we can cancel out 5 on both sides, or leaving you with just x to the third on top. So again, that tells us what to do. We see that 8 minus 5 is 3. So whenever we're dividing like bases, we're going to subtract the exponents. It is important to remember it's always going to be top minus bottom. And so just as long as you keep that in mind, you'll never go wrong. So again, pause the video for just a couple seconds here, or again, try to do it in your head and see what you come up with on this one. So if you if you subtract the bases, subtract the exponents, you should say, then we're going to have 7 minus 5 and 4 minus 8, and that's going to end up being c squared, and then d to the negative 4 power. Right now, we're going to leave it like that. We generally don't like seeing negative exponents in final answers. But for right now, we're gonna leave that alone, and we'll talk about how to kind of fix that in a few minutes. Okay. So again, this is what we call the quotient rule. And if you look in the textbook, you see this: x to the a over x to the b equals x to the a minus b. Again, remember, it's always top minus the bottom. Okay. One more. So how about this? Is what we call the power rule. What if we have x to the third, that quantity to the third power? Well, if you think about that, what do we really have here? We have 3 sets of 3, where each of these things is our x to the third. So we have 3x cubes, which in terms is 3x's times itself. And again, just like the product rule, how many do we have? That's 9. So that would be x to the 9th power. And I think you see what to do here. If it's a power to a power, we're going to multiply those two numbers. So anytime you see a power to a power, you're going to multiply the exponents. So I'll leave this here for you for a second. Kind of work through that in your head real fast. and see what you get. So we get, again, 2 times 4, 8, 4 times 1, which in this case would be 4, and then 3 times 4 would be 12. So that's the power rule. And again, that's how you would see it written. Okay, so those are really the 3 big ones that we talk about, is the product rule, the quotient rule, and the power rule. You don't have to remember the names of them, but just remember, if you remember that logical sense of what to do anytime you see a like base, then you'll be in good shape. Okay, but there are a couple more we got to talk about, and you do, and again, the rest of these you also saw in Algebra 1. But they're a little bit less commonly seen, so we're going to go through a couple more of these guys also. So let's talk about some non-positive exponents. Now, this is a demonstration I do all the time when I do this in class. So let's just pick any number. I'm going to pick 10 because we all know our powers of 10. So we know that 10 to the first is 10, and so on, and we can do that all day long. I'm going to stop at 10 to the fourth. But really, if you think about it, what's happening each time? Anytime you add an exponent, anytime you increase the exponent, then we have to multiply that previous answer by 10, right? But what if we go backwards? So if we start going backwards, then we would have to divide that answer by 10 every time that we reduce the exponent. So let's do that, kind of starting from here, and just see what happens as we get lower than 1. So again, 10 to the third is 1,000, 10 squared is 100, 10 to the first is 10. So now if we take away an exponent and do 10 to the 0, we have to divide 10 by 10. We know that's equal to 1. So that means 10 to the 0 power is 1. I'm going to highlight that there for just 1 second, because that's a really important point to make. And we're going to see it in a second here too. Anything to the 0 power is going to be 1 all the time. Okay? Well, we can continue the same pattern. So what if I take another exponent away? That's going to be 10 to the minus 1 power. If I divide 1 by 10, well, that says 1/10. Could write it as a decimal, easier to see kind of these patterns if I keep it as a fraction. I can do the pattern again, take away one more exponent. That ends up being 1/10 divided by 10, which is 1 over 100. But I could write that as 1 over 10 squared. And you see what happens here. And I can do it one more time. I can do it all day if I wanted to. I'm going to stop here. But if I take another exponent away, getting 1 over 1,000, that ends up being 1 over 10 to the third. Okay? So let's look at some kind of the key points here. This does work for any base. I chose 10 because they were easy numbers to work with. Anything to the 0 power is 1. If you don't write anything else down, you should probably write a couple of these guys down if you don't remember them from Algebra 1. But this is a big one. So anything to the 0 power is equal to 1. And also the negative exponent. Anytime you see a negative exponent, it's going to flip the base to the other side of the fraction. Okay? So again, if you look into a textbook, this is what you're going to see here. Anything to the 0 is equal to 1. And any base to a negative exponent, we can just put that as 1 over the positive exponent. If you see a negative exponent in the denominator, then that means we can just bring it to the top as a positive exponent. Okay? That negative sign just flips it to the other side of the fraction. Okay? So that's our other 3 rules. We got one more to talk about. Actually, so let's go back to that quotient rule we did a few minutes ago, where we had that answer, and I said we're going to go back and talk about that negative exponent. So is this mathematically correct? Yes, but it's what I call kind of funky. So we don't like negative exponents. So we can apply our new rule to that negative exponent. And so c d to the negative 4 power would actually be written as c squared over d to the 4th. And that would be a better way to write that as your final answer. Okay. Do note, the positive exponent stayed where it was. That c squared didn't move. It's still going to be on top. Only bases with negative exponent are the ones that flip. Okay. So again, I'm going to add my rules over here. So we got our 0 exponent and we have our negative exponent rules. We've got one more to talk about, and that is rational exponents. So what happens if you see an exponent that's a fraction? Okay. So there's no real rational way, if you pardon the pun, there's no kind of common sense way to do this. So I'm going to show you what it is. We're going to write this as a radical, okay, where the denominator of your fraction becomes what's called the index. And then the numerator of your fraction still remains as the power, okay? There's actually two ways you can write this. You can write it like this, or you can write it with still that index in there and then the a kind of outside the whole thing. Depending on what you're doing, one way might be easier than the other to simplify it at the end. But both of those are correct. We're just simplifying, going from a rational exponent to a radical. Okay. So let's look at a couple of examples here. If I have x to the 2/3, how would I write that as a radical? Well, just write that square root sign, put that bottom number on the outside, that's what we call the index, and then the squared. You can either keep it on the x, or you can just write that cube root of x kind of by itself and put the whole thing to the squared power. And that, again, they're both, all three of those things are saying the exact same thing. Okay. What if I want to go backwards? What if I have the 5th root of m? How would I write that as a rational exponent? Well, my power here is 1, so I'll write that as m to the 1/5 power. Okay? And that's how that works. So that's all the rules. So it's just going to be a matter of practicing and kind of knocking the rust off from your Algebra 1 days and simplifying these things. I do have a couple of examples that I'm going to run through. So here's one of them. And if you want to go and stop the video and try this on your own, or if you just want to kind of keep it going, and I'll run through this one. I do have a second example you can try on just a minute. So when I have a fraction like this, I personally like doing the inside of the fraction first and kind of simplifying all of those things and then dealing with the outside exponents. There's different ways you can do this. There's no real right way to do it. That's just kind of my personal preference. So I'm going to deal with the quotient rule. So I'm going to kind of leave this guy outside, and I'm going to deal with the quotient rule on each of these bases. Okay, so the quotient rule says I'm subtracting the top exponent minus the bottom exponent. So I'm going to end up with x to the 1st, 2 minus 1, y to the 1st, and z to the -2 power. And I'm going to leave that just how it is for right now. And then the next step I'm going to do, then I'm going to go in and look at the power rule. So I'm going to bring this -2 into each of these things. So again, the power rule says I'm going to multiply the exponents. So now I'm going to have x to the -2, y to the -2, and then z to the +4. Remember, negative times a negative gives me that +4. And then lastly, I'm going to apply my negative exponent rule as needed. You know, whichever variables have negative exponents, I'll flip. Anything that has a positive exponent, I'll leave alone. So that becomes z to the 4th, he stays on top, and then the x squared, y squared come down to the bottom, positive exponents. Listen, if you write this as your final answer with the negative exponents, you'll still get most of the credit. You may not get full credit, because a lot of times the directions will say write with positive exponents. But if you do the process correctly, a lot of times you'll at least get partial credit. Okay? So that would be your final answer. Last example, go ahead and try this one on your own. Go and pause the video for just a minute and see if you can work that out. I am going to give you one hint because we haven't really seen a coefficient yet. So in this case, we don't have any fractions. So start with the power rule in each individual parentheses, but don't forget about the leading coefficients. So pause the video for just 1 second and see what you can look for your final answer. Okay, so in the first set of parentheses, remember that power rule is going to come into each thing. So 2 to the third, a to the 12, b to the negative 6, c to the third. And then that negative 2 will come into the second parentheses. So a to the negative 2, b to the negative 10, c squared. And again, I'm not going to deal with the negative exponents yet. I'm just going to kind of do that all at the end once everything's all combined. Okay, so now I'm going to apply the product rule. So combine your like bases by adding the exponents. So we have 8, a to the 10th, 12 minus 2, b to the negative 16, negative 16 plus negative 10, and then 3 plus 2 is 5. And if you're wondering, just to make sure you see where the 8 comes from, this is 2 to the third power. So that's just a number, so that's the kind of where that 8 comes from, just to make sure you see that. And now finally, I'm going to apply my negative exponent rule. The only negative exponent I have on the whole thing is the negative 16. So he's going to go down to the bottom. Everything else is going to stay where it is. So your final answer would be 8, a to the 10th, C5, all over b to the 16th. And that's your final answer. Okay, so that's your logical approach to exponent rules. Again, you've done this in Algebra 1. I'll put the screen back up here. This will be the last, I'll kind of leave this up here. If you need to write those down, if you haven't yet, I encourage you to do so. But again, it's, if you remember just kind of the common sense, the only thing that's kind of not common sense about these things is the rational exponent rules here on the bottom right. Everything else, though, if you just remember kind of how they work, they're pretty easy to remember kind of going forward. Hope you found this video useful and informative. If you have anybody that's any younger friends that are in Algebra 1 currently, or feel free to share this with others that might be doing the same kind of thing right now. If you have any questions, please feel free to email me or email your own teacher. There will be a short assignment put up on Google Classroom for us based on the same stuff this week, and that'll all be up at the same time on Monday morning. Please keep in touch. Feel free to share anybody that you might need help with this, and feel free to subscribe for later videos. Take care of yourself, stay well, and keep studying.